Hello Kai, I thought I would just go through your questions on your email with a video. It may have to be separated into two because there's so much here and I don't want to make the video too long. So let's do that. So part A, we're doing great with 1D, 2B, 3A, let me have a quick look. Yeah, I believe so. And you are correct about the question 4. The actual expected value there should be 1.71. There seems to be a typo on that document. So you're right about that. So let me just need to switch screens here for a minute. Okay, for number 5, you're right, that's false. The 68% is 1 standard deviation, not 2. And for number 6, we're looking there for a z-score. So you just want z equals 1. You don't need to convert that, okay? So if it asks for a z-score, it's just asking for the actual z calculation. If it's asking for the percentage area under the graph or the probability, that's the decimal that you take from the chart. So looking at question 7, the area under the shaded region, so you're going to look up z at 1.1 and subtract it from z at negative 1.1. And so you've got 0.72866 there, and you're okay to round off to, I'd say 4 decimal places there in regards to your question about decimal places. So let's just scroll down here. Here we go. Oops. Okay. And let's get back to work. All right, so for part B, they're asking you about the binomial distribution and whether or not that is an example of it. It's not, because a binomial experiment is an experiment that has only 2 outcomes, because we always define our binomial experiments and binomial distributions as a success or a failure, and there's nothing else. So flipping a coin or having a male or a female child, those kinds of things, you have one of 2 outcomes to choose from, and that's all. And those are binomial experiments. Anything else, such as this example with the color of eyes, because we can have brown or blue or green eyes, does not make it a binomial experiment, okay? So for part C, you are correct. For part C, for all of those calculations, everything looks good there for number 1. For number 2, it looks good also. And number 3, I just need to scroll down, but I'm seeing already that you are correct about the number of digits. That's also a typo on that document, and so it should just be a 4-digit number. And so you are approaching that correctly. It was just that you didn't have the right information given in the question, and looks like you've got the right answers for everything there. So for 4, if we have a, yeah, okay, sorry, for 4A, you're right about that. For 4B, yep. And for 4C, let me just check that question here. So 4C, either both cars will start or neither car will start. So that's an or question, and those 2 things are mutually exclusive, and so we just need to add those 2 probabilities. So you're correct there. And then for D, we have exactly 1 starting, and that percentage I think should be a bit higher. I think you need 90 there because you've got, so you've got 10 plus 40 minus the probability of, sorry, I'm looking at the wrong thing here, just a minute. Yep, sorry, okay, it's a little confusing because I'm looking at 3 different places at once here. So for D, it should be the probability of 1 starting plus the probability of the other one starting minus the probability that both will start, which is your 40%, and so you should end up with a 90% chance that exactly one of them will start, okay? So let's take a look at question 5, and this is not cooperating. Just a second. Okay, got that fixed. So for 5, you're right with 1/2 for A, you are right with 1/26 for B, and you are right with 5C. That should be a 53% chance there. Yeah, that's good. Okay, for part D, question 1, okay, so you're saying that you're confused by the wording there. So what you want to do there is, yeah, that wording is a little tricky. I think what they meant there was the probability of success on the first flip for 1B. All you need to do here is tree diagram or list your outcomes either way, you know, like tails, 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 heads, heads, heads. There's 8 outcomes altogether, and all you need to do is count the appropriate number out of the total of 8 to find these probabilities. So for B, I think that what they were asking there was the probability of success on the first flip. So you want to count up all the ones that would be, is it tails or heads? I can't remember. For the first flip only, and write that as a probability. And then what are we looking for? Heads, right? So find heads for the first flip and write that as a probability out of 8. All right? So question 2, if we still have time here, the video gets long and then it's hard to load. I think what I'm going to do is make you a second video for the rest of it.